circuit and electric current. So this is the second topic what you are having. So in this, what are the topics you are going to discuss means first what is meant by electric circuit and what are the various types of circuits are there and electric current and what are the two directions of current and how to measure the magnitude of current. So first, what is meant by electric circuit? It's a type of a closed path. Electric circuit is considered as a closed path through which the current will flow from one terminal towards the another terminal. For example, if you are taking a batteries in and then we connected along with the plug key and it's connected along with the bulb. So initially the key is kept in off. So once the key has been turned on, what will happen means the electric current will start to move in this closed path. That means a path which is taken by the electric current is nothing but called as the circuit. Yeah. So whenever the switch is kept in on, so by that time we'll be calling the circuit as a complete circuit or you can call it as the closed circuit. That's same as it is, just in the reverse order. Whenever the switch is kept in off, so by that time we'll be calling the circuit as open circuit, incomplete circuit or broken circuit. Based upon the connection, how we are going to connect the electrical component, we are going to divide the circuits into three basic or main categories. What are three types of the electric circuits are there? Simple circuit, series circuit and parallel circuit. So first, what is meant by simple circuit? So it's a circuit which is going to consist of only one cell, one switch or a key and one electrical component. Here what is the electrical component you are taking? An electric bulb. So if you are going to connect like this, a cell, a plug key and a bulb. If the circuit is like this means, then the given circuit is called as a simple circuit. That means all the components need to be in a form of a one. Only one cell need to be there, one key need to be there and one electric bulb. If it is like this means that type of circuit will be calling it as the simple circuit. So what is the second type of circuit you are having? Series circuit. Series means here the combination is going to be in the form of a end to end. Combination is in a form of end to end. Now let's take 2 to 3 bulbs are there. Let's take this the first bulb B1 and this is the second bulb B2 and this one it is the third bulb B3. Let's take the end of the bulb A as A, B, C, D and third bulb as E, F. So now what we are going to do? We are going to connect the end B along with the end C. That means the connection is in a form of end to end. Here, end D is connected to the end E. If you are connecting like this means that type of combination will be calling it as the series circuit. That means whenever the components are connected in a form of end to end. So if you are looking in this diagram, the end of the first bulb is connected to the end of the second bulb. Then we can say that the given combination is in the form of series combination. And then the next one it is called as the parallel combination. This is the most important application where you are using in our home. That means whenever the electrical components are connected to the common points. So if you are looking in this diagram, so all the three bulbs are there. All the three bulbs are connected to one common point and the other end also is connected to the common point. If the given combination is like this means, then we can say that the given circuit is in a form of a parallel circuit. Next important topic, electric current. So what is meant by electric current? Electric current is nothing but called as the amount of charges which flows through the conductor per unit time. Yeah. For example, let's take a conducting material. Already we said the electrons only is going to flow. Let's take an electron is over here in order to flow from one end of the conductor towards another end. That means this charge will take some time in order to flow from one end of the conductor towards the another end. So that's what we'll be calling it as electric current. And this one simply we can define it as electric current is equal to the rate of flow of charges. Either you can write this definition or you can write this one. And what is the formula to calculate the electric current means? Current is equal to charge by time. So and this is the second formula what you are going to learn in this chapter. Current is represented by the symbol I, charge is represented by the symbol Q, and time is represented by the symbol T. Clear? So what is the formula we are going to use in order to measure the current over here? I is equal to Q by T. So this one also, if you are going to remember in a triangle, I, Q, T. So if you are going to find I elements, the formula will be Q by T. If I am going to find Q means the formula will be equal to I into T. Why? Because these two are located nearby each other, then we can say that it's in a form of a multiplication. Suppose if they are asking us to calculate time, then what will be the formula? Time is equal to Q by I. So if you are remembering triangular method, it will be easier for rearranging the formulas. Next, unit of current. Since current is a measurable, we need to know what is the unit of current. The unit of current is ampere. So what is the unit of current? Ampere, and ampere is represented by the symbol A. And then, so it is named after the scientist Andre Marie Ampere. And what is the another unit of current? The other unit of current is coulomb per second. So what is another unit of current? Other unit of current is coulomb per second. How we obtain this unit means from the formula. So what is the formula to calculate current? I is equal to Q by T. What is the unit of Q stands for charge. And what is the unit of charge? Coulomb. And then the denominator we are having time. Time unit is second. Then we can write it as coulomb per second. While I am going to write in a symbol, we will be writing it as C by S. But there is a certain rule is there in order to write the unit. Always the unit need to be written only in the form of a negative powers. So we can write it as CS power minus 1. But while you are pronouncing, we need to pronounce in this format coulomb per second. So now, how we are going to define this 1 coulomb? Sorry, next topic what we are having it is how to measure the magnitude of electric current. Since it is a quantity which is measurable, we need a device. So without a device, we can't able to measure the magnitude of current. So by using what device you are going to measure means by using the device called as ammeter. And what type of device means ammeter is a type of a low resistance device. And reason why, because ammeter is used to measure the magnitude of current. Since it is used to measure the magnitude of current, the ammeter need to be in a form of a low resistance device. And then where the ammeter need to be connected means always the ammeter need to be connected only in a form of a series. And why? Because in series combination, the flow of current, that means the magnitude of current will remain the same. In series combination, the magnitude of current remains the same. For example, let's take a circuit is there. So if you are observing, all the 4 bulbs are connected in a form of a end to end. That means it is in a form of a series combination. And the question if they are saying that the amount of current which is passing through the first bulb is 1 ampere. Calculate the amount of current which is passing through the 4th bulb if they are asking means the same amount of current only will pass over here. There won't be any change in the magnitude. The magnitude of current in series combination will remain the same. So if I am connecting 3 to 4 ammeters over here, let's connect 1 ammeter in this place and 1 ammeter over here, and in this end 1, and the middle of the 2 bulbs, let's take 1 more ammeter. Is it clear? And in the question they are saying that the amount of current which is passing through the reading which is shown in the second ammeter. Let's take it as let's take the same value as 1 ampere itself. What will be the reading shown in the fourth ammeter? Same amount of current only will flows. So wherever you are connecting the ammeter in series, the magnitude of current will remain the same. The magnitude of current will remain the same. The magnitude of current, it won't even change. If they're asking the question whether there will be any difference in A1 and A3, by the time what will be your answer? Yes or no? No. So there won't be any difference in the ammeter A1 and A3. Reason, all the ammeters are connected in the form of a series. Series, the flow of current will remain the same. Next, what happens when the ammeter is connected in the form of a parallel? So what will happen over here means the ammeter will get damaged. So by mistakenly connected the ammeter in this format. Let's take a circuit as in a plugging and a bulb. So across the ends of the bulb, if I connect the ammeter in this order means, that means the ammeter is connected in the form of a parallel. So in this condition, what will happen? The ammeter will get damaged. The ammeter will get damaged. Reason, due to the short circuit only is going to happen. So why? Because whenever we are connecting more number of electrical devices in a form of parallel combination means the net resistance will get decreased. So due to the decrease in the net resistance, more amount of current will pass us through the ammeter. That means the amount of current which is passing the circuit will get increased. So due to the increase in the current, short circuit will create and the ammeter will get damaged. So this is the reason we should not connect the ammeter in the form of a parallel. And how we need to connect? We need to connect the ammeter only in the form of a series. This is the right and this one it is the wrong representation. Next. How to calculate the least count of ammeter? Not only the ammeter, in order to calculate the least count, there is a formula is named. So by using what formula we are going to calculate the least count means least count is equal to range by number of division. So this is the formula what you are going to use in order to calculate the least count of any device. So what is the formula over here? Least count is equal to range by number of divisions. Here I given value is given like this means it represents the given device is ammeter. The given device is ammeter. And if I am using ammeter, the unit of current, it will be in a form of ampere. The unit of current will be in a form of ampere. Instead of this A, suppose if they gave the symbol like this means MA. By that time, the given device is milli ammeter. The given device is milli ammeter. And whenever you are using milliammeter, the unit of current is expressed in a form of milliampere. These and all you need to remember. The upcoming topics will be discussed. And then, if it is given in a form of mu like this symbol means, that means micro. It represents the given devices micro ammeter and unit is expressed in the form of microampere. Now we'll calculate the range of this given device alone. So in order to find the range, first choose any two values. So what are two values I'm going to choose means one is 0 and another one is 0.5. Out of the two values, which one is considered as a maximum? 0.5 is the maximum. Subtract the minimum value from the maximum value. 0.5 minus 0 again is going to be 0.5. Now this is going to be the range of the given device. So what is the range of the given device? 0.5. Now count how many divisions are there. Divisions means the lines. So this is going to be 0. Start from here. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Totally how many divisions are there? 10 divisions are there. So 0.5 by 10. So in order to reduce the decimal, what you are going to do means you are just going to multiply and divide by using 10. 0.5 into 10, 5. 10 into 10, 100. So 5 by 100, 0.05. And what is given either a ammeter or milliammeter or micrometer? Ammeter. If it is given in ammeter, then the unit need to be in a form of a ampere. That means what is the least count of the given ammeter over here? 0.05 ampere. Least count in the sense the smallest value which can be measured by using the given device. So by using this device, what is the smallest value of current you can able to measure? 0.05 ampere we can measure. Suppose if a negligible amount of current is passing in the circuit, negligible in the sense a small amount of current is passing in the circuit means. So by that time, what we need to do? Yeah. So you can go along with the other two devices which is called as milliammeter and another one is microammeter. So when we'll be using these two devices, whenever a small amount of current is passing through the circuit. So what are two devices we are going to use over here? One is milliammeter and another one is microammeter. So whenever you are using milliammeter, the unit of current is expressed in a form of milliampere. And if you are using micrometer, the unit of current is expressed in a form of microampere. So how it will be there means the circuit diagram will be like this. So if you are observing in this given diagram, here it's MA is there. This represents the given device is milliammeter. The given device is milliammeter. And if you are seeing over here, here we are using a Greek symbol. So this Greek symbol we need to pronounce it as mu, and here it stands for microammeter. Here it stands for microammeter. So whenever you are using microammeter, the unit of current is expressed in the form of microampere. The unit of current is expressed in the form of microampere. And if you are using milliammeter, the unit of current is expressed in the form of milliampere. These things we need to remember carefully. So check the device whether it is given A or MA or mu A. If it is given as A means the unit of current is ampere. If it is given as MA means the unit of current is MA, milliampere. If it is given in mu A means the unit of current is microampere. If it is given in ampere means we no need to convert anything. If it is given in milliampere means by the time we need to convert. For example, the amount of current passing through the circuit is 5 milliampere. If it is given means this smaller unit we need to convert into SI. In order to convert, we are going to multiply the given number. In this question, what is the given number? 5 is the number which is given. So this number we need to multiply by 10 to the power of minus 3. If you are multiplying like this means this milliampere can be converted into ampere. That's same as it is. If it is given in microampere, for example, let's take the same magnitude itself, 5 microampere. So in this case, what you need to do means we are going to multiply the given number by using 10 to the power of minus 6. For MA, 10 to the power of minus 3, and for mu A, 10 to the power of minus 6. This conversion we need to do, and after converting only, we need to solve the numericals. Clear? So let's try to calculate the least count of this given ammeter. So first we need to find the range. In order to find the range, we are going to choose two values. One is 0 and another one is 20. Out of these two values, which one is the maximum? 20 is the maximum. Which one is the minimum? 0 is the minimum. So now subtract the maximum value, minimum value from the maximum. So what is the maximum? 20 minus 0. 5. And now count how many divisions are there between 0 and 20. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 divisions are there. So 20 minus 0, 20 by 10. 0, 0 cancel. 2 by 1 is going to be 2. And check what unit is given over here. M. So the least count of this given ammeter is going to be 2 milliampere. Now if you are coming for this condition means, choose any two numbers. What are two numbers you are going to choose? Not only 0 and 20 alone. For example, now I am choosing these two numbers. What are two numbers I choose over here? 40 and 60. Even if you are solving like this also, you'll be getting the same answer. In these two, what is the maximum? What is the minimum? 40. Why? Count how many divisions are there between 40 and 60. 0, 1, 2, 3, 4, 5. 60 minus 40, 20. 5. 5. 1 paisa, 4 paisa. So 4, what is given? Micro. 4 micro ampere. If I am going to convert this one means I can write it as 4 into 10 to the power of minus 6 ampere. Clear? So for example, like this I am choosing. What are two numbers I choose? 0 and 20. So what is the maximum? 20 minus 0 by 5. 20 minus 0, 20 by 5. If I am simplifying, I'll be getting the same answer. So whatever the number you want, you can choose, that is a wish. But if you are choosing one number as 0 means, it will be easier for subtraction. Clear? Reason, we are going to subtract any number by using 0. Clear? We are going to get the same number. Next, directions of current. So how the current is going to flow in the circuit, we are going to divide the direction into two categories. One is called as conventional current and another one is called as electronic current. Electronic current, we can also call it as electron current. So first, what is meant by conventional current? So whenever the charges, that means whenever the current is flowing from higher potential towards the lower potential. Higher potential means it's called as positive terminal and lower potential means it's called as negative terminal. Let's take a simple circuit as this. Yeah. This larger vertical line is the right. This is considered as a positive and the smaller line is considered as the negative. Here also the same. The larger line is called as positive, smaller line is called as negative. So when the current is flowing from higher potential to lower potential, that means from positive terminal towards the negative terminal, that type of current will be calling it as the conventional current. And if you are considering the current, that means the charges are flowing from negative terminal to positive terminal, that means from lower potential to higher potential, that type of current will be calling it as the electronic current. And here, which current you are going to consider means, we are going to consider only the conventional current. We are going to consider only the conventional current. That means from higher potential to lower potential. Here the diagrammatic representation of conventional electronic current has been shown over there. So if you are observing, always these two will act in two different directions. That means the conventional current and electronic current will be acting in the opposite direction. Clear? Next, quantity of electric current. Quantity in the sense, we are going to say whether it is a scalar quantity or it's a vector quantity. Current is a type of a scalar quantity. Current is a type of a scalar quantity. But this current is having both magnitude and direction. The lower class we learned, if any quantity is going to have both magnitude and direction means it's considered as a vector. But even though current is having both magnitude and direction, we are calling this one as scalar. Reason, current does not obey the vector law of addition. It won't obey. That is the reason we are calling this one as a scalar. This concept is not in class 10, but in one of the model exam they asked this question. What type of quantity or current is a dash quantity? Current is a type of a scalar quantity. Don't forget. Next. What is an electric circuit mean? And in text question. So what is meant by electric circuit? Electric circuit is defined as the closed continuous path through which the current flows from one terminal, that means from the positive terminal towards the negative terminal. Clear? So what is meant by electric circuit? Electric circuit is the closed continuous path through which the current flows from positive terminal towards the negative terminal. Next, define the unit of current. Sir, we all know the unit of current is ampere. But in the question, they ask us to define not only this word, even if they are using the word state the unit of current or whatever it is, or define the unit of current. By that time, we should not write this answer alone. This ampere we need to define. So how we are going to define 1 ampere? 1 ampere is defined as 1 coulomb of charge is flowing through the conductor in 1 second. So I will define 1 ampere. 1 ampere is defined as 1 coulomb of charge is flowing through the conductor in 1 second. If they are asking for 2 ampere, by the time how we can define 2 ampere is defined as 2 coulomb of charge is flowing through the conductor in 1 second. So this is the right representation. Suppose if you wrote like this means 2 ampere is defined as 2 coulomb of charge is flowing through the conductor in 2 seconds. Is that right? No. Why? Because if you are simplifying these two numbers, again what will be getting? 1 coulomb per second. This coulomb per second you can also write it as 1 ampere. Question is for 2 ampere, but we gave the answer in the form of a 1. So it is the wrong step. Clear? So how we need to define this one? 2 ampere is defined as 2 coulomb of charge flowing through the conductor in 1 second. So after simplifying the two numbers, we need to get the same number what is asked in the question. For example, I am writing like this. 2 ampere is defined as 4 coulomb of charge is flowing through the conductor in 2 seconds. Is it right or wrong? It's a right statement. Why? If I am going to simplify these two numbers, 4 by 2, 2. Coulomb per second is something called as ampere. I got the same number as it is what is asked in the question. Even you can use the numbers like this also. No problem. Next. An example question. A current of 0.5 ampere. So whenever you are going to solve any numerical, first write the given data. Here what is the given data? 0.5 ampere. Ampere stands for current. Then what is the symbol of current? I. I is equal to 0.5 ampere. Next read the question. Is drawn by a filament for an electric bulb for 10 minutes. Minutes means is it related to time? Then t is equal to 10 minute. Since minute is not the SI unit, we need to convert this minute into second. In order to convert into second, we are going to multiply the given number. What is the given number? 10 into 60. So why we are multiplying like this means in each minute how many seconds will be there? 60 seconds. Then in 10 minutes how many seconds will be there? 10 into 60. 10 into 60 it is going to be 600 seconds. Now we converted the time into second. So after that, find the, it's not nature, it is amount of charge. That means you are going to calculate the value of Q we are going to find. So by using these three data, what formula we can use? I is equal to Q by T. If I am going to find Q means the formula rearrange it as Q is equal to I into T. So Q is equal to, what is the value of I? It is given in the question, 0.5 into, what is the value of T? 600. If you are having any confusion in the decimal place, forget all the decimals as well as 0. Multiply the number alone. So what are two numbers are there? 5 and 6 alone is there. 5, 6 are 30. How many zeros are there? 1, 2. Add the 2 zeros at last. Check any decimal place then is 1 digit is there after the decimal. So from the right, after 1 digit, keep the decimal. If it is 0 means cancel that number. So then what will be the final answer? Q is equal to 300. Since it is a physical quantity, I need to write the unit. So what unit we need to write over here? Coulomb. Yeah. Coulomb is represented by the symbol 3. Then what is how many charges then? 300 coulomb of charges are there.